and sleepy. Wow, studying, good. I'm fine, thank you. Hungry. Oh my God, I did not prepare anything for you. Emo. Hey, I don't understand. What is emo? Huh? Depressed. Why are you depressed? Hey, be happy. Okay? I'm excited for breakfast later. Then we have to go out. Okay? Natalie is getting KFC. Oh, great, great. Then I have to go out and get for you. Wait for me. Okay, guys? Natalie is getting KFC. Good, good. Okay, great, guys. Some of you say good, some of you say happy. Okay, great. I will arrange a makan for you. Okay? I don't know when, but definitely I'll give you one. Okay? So now, let us see continuation of last class. So I want to know, we have learned machine learning. So can someone tell me what do you understand about machine learning? Come again? Come again? Subset. Louder please. Subset of AI. Okay? Okay, to identify pattern from labeled data or unlabeled data. Okay, using data to get experience. If you give the data to learn a machine to learn the data, okay, something like that. Learn the pattern or trends from the data, okay. Okay, analyze data using algorithm to predict, to estimate.
Predict something with data.
Okay, predict something using data set. Subset of AI. Predict future. Learn from the data set. Learn AI, okay, AI to mimic about the human. Okay, so whatever you say, it covers machine learning. So firstly, machine learning is what? Subset of AI. So machine learns from the experience. The experience here is from where? From the data set. So it learns, the machine, using the algorithm that you use, the machine learns the pattern, trend of the data set to predict and to estimate. So that is machine learning. So now we come back to subset of machine learning, subset of AI is machine learning. So now we are going to look at types of machine learning. Okay? Okay, types of machine learning. I just want you, there are 4 tables here. One table give me one type of machine learning. Supervised machine learning, unsupervised machine learning, semi-supervised machine learning. This table, reinforcement machine learning. Very good. So it was a continuation of last week. So we can see here. So machine learning types, you have supervised machine learning, unsupervised, semi-supervised, reinforcement, housing price prediction, medical imaging. Unsupervised, you have these two. We are going to concentrate on supervised machine learning. Supervised machine learning, you have house price prediction and medical imaging. House price prediction, what can you say about it? House price prediction. House price. It is a number, numerical variable. When your target, so when you call supervised, okay, before we go into this, supervised machine learning is what? What is supervised machine learning? Can someone, you say supervised machine learning, can you give me one sentence about supervised machine learning? It is a labeled data, okay? You want to use, want to do supervised machine learning, The data set must be labeled. Okay? Yeah? Can you talk about the label data? What is the label data you call it? Yeah? Yeah, label data is one of the columns in the data set. It is another term you must know. It's a label data set. Target variable. Okay, label data set, it must have a target variable. So, if you have a target variable, you can use supervised machine learning. If you do not have target variable, you use unsupervised machine learning. Good. So now supervised machine learning is in this section. You have two types. Okay. So target variable. If your target variable is numerical, you use what? Regression. If your target variable is a categorical, you use classification. Follow? If your target variable is numerical, can you give an example? House price. Housing price. Okay? If your categorical variable means, can you give an example of categorical variable? Medical imaging. Okay? Medical imaging. But I don't see the category there. Can you tell me how it can be a categorical variable? Okay, whether the image has a tumor or do not have tumor. Yes, no. It's a categorical variable. Okay, so now here housing price, it's a target variable is numerical, so you use regression. If your target variable is categorical variable, then you use class. Okay, so under when your target variable is numerical, you use regression. There are so many regression, but today I'm going to do only a simple linear regression. Okay guys, simple linear regression. So once you see any data set, you must look for target variable exists or not. Okay, if exists, which is your target variable? Once you know your target variable, check it is numerical or categorical. Once you know it is numerical, there you go. Use regression. If your target variable is categorical, then you must think of classification algorithms. Okay? This is the first thing you must know. If you do not have target variable, what you should do? You go to the next machine learning, unsupervised category. Follow? Okay, so that is the first thing you should look at it. Okay, now we are going to look at supervised machine learning. Your target variable is what? Numerical variable. If it is numerical variable, you know you use regression. This is classification. You can't draw a straight line. Here you can draw a straight line. Okay, this is classification regression. In this case, regression, very good, straight line. Not necessary all the time you will have linear regression. If a straight line, you call it what? Linear regression. If don't straight, let us say you have a curve going up and down. Okay, let me take here. Okay, let me say here. Okay, let us say my line is like this. Okay, it goes up and down. Okay, is this a linear? No. But in this case, lucky, it looks a linear. So if linear regression, no problem. If it is not linear, can you do or not? Can. How to do? If you think it is a target variable is numerical, you can't do classification. You have to do regression. But it is not a straight line. What can you do? Think. Very good. Transformation. Okay. Do you know transformation? How is that? If it is y equals to x squared, you must change it to linear. Linear rules you learn. Okay, you have to transform it to a linear equation. Okay, if you want, we can do it in another session. You still can do. Okay, what must you do? Before you do linear regression, you have to do transformation first. Once you have done transformation, then you can do linear regression. Follow? So don't think if there is no. That's why when you do a linear regression, first step is to do what? You take your data. If you think it is a target, if the target variable is a numerical variable, what do you do? First thing, you draw. Draw, sketch, look at it whether it can be straight line or not. If it can be a straight line, no transformation, you are safe. If it is a going curve like that, do transformation. Change the data to this format. So you need to do transformation. Okay? So now we are going to look at regression. Linear regression, so no transformation. If you want to know transformation, then we will do another training for that. Okay, now regression models. Okay, what do you do first? Regression model. There is a relationship between one dependent variable and explanatory variable. Do you still remember what is the, just now you say target variable, right? Okay, the same term, but here you call it dependent because it depends on that. Okay, so an explanatory variable. Explanatory variable, sorry. Okay, what does it mean by explanatory? You have other features, right? You in a data set you will have how many columns? Can you tell me? Sometimes 10 columns, sometimes 2, 3, 4, 5, depends. Correct? So what you do? The target variable is your dependent variable. The rest of the columns are called explanatory. It is explaining about the data set. Okay? You have few terms for that. You can call it explanatory, independent variable, some more what? So many terms you can use. Okay? Now, you are using equation to set a relationship. What you are doing? Relationship. You have numerical variable and the explanatory variable can be numerical, can be also capital. It can be combination of both. Okay? So now you are looking at the relationship. So you will have one dependent variable, one or more, either numerical or categorical, or you can also call it explanatory. Independent, explanatory. Okay? Okay, yeah? So same term. If you read article, you come across all these things again and again. Okay? What are you doing? Either you predict just now house price or estimate the house price. Okay, now if you have regression modeling steps, what do you mean by hypothesized deterministic component parameters? So your parameters here, your relationship of the house price and number of rooms. If the house price will go up or not, if your number, okay, I'm giving a very simple example. House price, number of rooms. Okay? House price will go up or not when your number of rooms go up?
Yes, yes.
Definitely will go up. Good? Okay. How much it will go up? One room extra? $2 go up, 200 will go up. That is your parameter you are going to measure. Follow or not?
Yes.
Okay. Number of rooms. What else you will? Number of bathrooms very important. Okay? If number of bathrooms, if one bathroom you add, what would be the price will go up? 500? I don't know. Or 1,000? Or 5,000? That is your deterministic function. This is what you are going to measure. You understand or not? Okay? Specify probability distribution of random error. What is error now? You have learned error. I guess so. What is error? Can someone tell me? What is error? Anyone have idea? What is error? No, is it? Error. Who knows? Okay. When you do linear regression model, you are predicting, right? You are predicting. So your prediction value and the actual value you compare. When you compare, you take the actual value minus the predicted value, what do you get? That is called your error. You understand or not? If what you predict and what is your actual value same, that's great now. You think your model can be like that? Very rare cases. Okay, so the error comes, you predict one value, actual value minus your predicted value, you get error. That is called error. So now we want to see whether what type of error. If the error always say always 5 or always 10 or it goes up and down. So you are looking at the distribution of the error. Follow? Okay? Now in regression, if they say error means, do you know what is error? The value between actual minus predicted. That's your error. Okay? This is a very important term that you should know. Okay, evaluate the fitted. First you check the error, then you evaluate the model. How good is the model? How are you going to evaluate? I'm going to give what are the metrics you can use. Okay, you evaluate. So then you use the model to predict and do estimation. Can guys? Okay, now define the, okay, I told you beginning earlier, starting of this slide, what did I tell you? Look at the data set, you must know whether you have target variable or not. If you know there is target variable, then you know it is a dependent variable, the rest independent variable. Okay? Okay? That is the first thing you should do. Second thing, hypothesize the nature of relationship. I told you, you want to look at the house price. If number of rooms go up, price will go up or go down. That is go up. That is called coefficient sign. Sign means go up or go down. Okay? Positive or negative. Functional, either linear or non-linear. Linear means if you go 1, 2. If 1, 2, 2 means 4. Depends. Whether x squared. The graph is not a straight one. Okay? So you have two things here. Either up or down, positive, negative. This one either linear or non. Okay? Now, how you are going to do this theory? Whatever things you do, house price, who will be good in predicting house price? He's good. Are you in property guru? Our friend say he's good. So if you are in property guru, then you are very good, isn't it? If you are in real market, you are very good. Correct? So what does it mean? You must be active. If you talk of imaging, correct? Who is smart? Doctor, look at the image. Oh, you are a doctor. What is he saying? You are a doctor, man. Okay, so what I'm trying to say here, you take a data set, you want to analyze it. Somebody who is good in that field, you must have in your data set. I don't know how many of you want to be a data scientist, so you want to analyze data or data analysis. Okay, you want to analyze data. Okay, data come from property guru, so you better to have someone in the property guru to advise you about the data set. You understand? So that is important. That's why it is mathematical theory. Linear regression is what? It's a maths, right? Linear function. You know linear function. Okay, now you are using it to create a model, develop a model. Okay, previous research you have done. Previous research in this field. Okay, now common sense. Just now we use common sense, right? Number of rooms go up, price definitely go up. Okay, common sense. Okay, types of regression models. You have simple. When you have simple mean target variable 1, always 1. Independent variable also 1. That's why it is simple. Okay, if you have multiple, more variable, like just now, house price, number of rooms, then it's going to be simple. If you have house price, then number of rooms, number of bathroom, and some more what? Area, then that's going to be multiple regression. Okay? Then some more. Linear, as I told you, it can be a straight line or not straight line. Non-linear. Same. Multiple also, it can be straight line or not straight line. This one, straight away we can apply. This one, you must do, just now, must do what? Transformation. Okay, change the data into a different format. Okay, so now I'm only looking at very simple one explanatory variable. Can guys?
Yes.
Okay, any question? Okay, okay, now let's see. Okay, now your turn, huh? Okay, your turn. Okay, I think supervised learning. Okay, can you tell me what is linear regression? I don't want to ask supervised machine learning. You all are smart really. Just tell what do you understand by linear regression? Good. Identify the association between dependent variable and explanatory variables. Very good. Linear regression is a data analysis technique that predicts the value of unknown data by using another related and known data value. Okay. Analyze the relationship between two or more variables. Yes. Always perform straight line. Yes. Linear regression, so straight line. If it is not linear, then no. Just this one, association only. Okay, only 4 of you give answer. The others don't know the answer. Okay, you have how many in the class? 4, 7, 10. Oh, linear regression is a supervised machine learning algorithm used for predicting a continuous output variable. Okay, based assumes that there is a linear relationship between the input independent variable and the output dependent variable. Very good. Young, very good. Young, shall we give him prize? What prize? What is that? What is that? We don't have a counter for that. Yeah. Go to Europe lah for that. Next time I should have prepare some sweets. Okay. Yeah, sweets. Okay, next one I plan the date and then I tell you. Okay, that's all. Okay, that's good. This is a complete one. Okay, linear regression, you are looking at the relationship between two. Correct? Okay, now we are going to the next slide. I hope you are not bored. Huh? Okay, let us see. Regression linear. Okay. So first of all, okay, this is linear what? Equation. Correct? Did you learn this in your foundation or in your undergraduate? I don't know when you learned. This is what your teacher would have taught you. Y equals to mx plus b, linear equation, straight line. Okay, your m is what? Your slope. How to calculate your slope? Change in y over change in x, that will be m. B is here. Okay, now, you see, it is a straight line. That means all the points are on that point. Okay? Okay. All the points are on that dot here. On that. Okay? Okay? Every points are on that line. So that's why it is a equation. Okay? Okay, now. This is again and again, look, linear equation. Y equals to mx plus b. Okay? We are going to look one explanatory variable. So here, x is your explanatory. Y is your y, you can say it's your house price. X is number of rooms. That's all. What is b? Where it cuts your y, intercept. Y intercept. Any question? When your x is 0, I mean number of rooms, no room, studio lah. No house, you know studio unit, right? No room, right? Just enter, open like this. Correct? So that one, price is this amount. Starting, no room, this is the price. Follow? Okay? Now, you look at the term. No more linear equation. Linear regression. Do you know what is the meaning of regression? equation y equals to mx plus b. Now you look at this one. Relationship between variable is a linear function. Y linear straight line. Now, this is your yi. Yi. You might ask me why I. Can you relate it to your data set and tell me what is I? Anyone? In your data set, what do you have? Number of columns, number of columns, you know. Rows, row number 1, row number 2, row number 3. So your I is row number 1, row number 2, row number 3. Okay? So this is your dependent variable. If you look at your house price, this is your house price. First row, house price. Second row, house price. This is what? Population of y-intercept. This is when your no room, we talk of the house price lah. Room is your explanatory. If no room, okay, this is the price. That is population y-intercept. And now, xi is number of rooms. Number of rooms, independent variable. So this is what you want to find out. If one room, you add one room, what would be the price? If you add two rooms, what would be the price? This will tell you population slope. This is what parameter you call what? Beta 0, beta 1 are parameters which you are going to calculate using the formula. Okay? Now, population. Remember this? Error. What is error? Actual value minus the predicted value for the first row, for the second row, for the third row. So what is the difference between linear equation and regression? I go back. Y mx plus b. Regression. Y beta 0, beta 1 xi. Error. Additional one term is what? Error. Follow? Why error? Then not all the points in the straight line. Here, it is not. Follow? Okay. So you can see that. Okay? Now, can you get all the houses in Malaysia and predict? Okay. That is your population. Okay? That's why you have like this unknown relationship. But it is not possible. So what you do? Take a sample. When you take a sample, the term will be like this. What is this? Why you have a cap? You are estimating. Why you have a cap? Estimating. Why you have an error? Also cap. Estimation. Follow? Okay. Now, you see? Just now I told you what? All are on the same line, linear equation. Here you are trying to get a line, straight line. Whether this line good or not, I don't know. Can this one good or not? Okay? Which line is good? Which line is good? Can you tell me which line is good? How to predict which line is good? Huh? Go up is good. Tell me which line is good. Just think. Which line should be good? Just I want you to think. Just simply give any answer. Which line should be good? Which line should be good? Which line should be good? Just tell. You see that? Just tell one answer from this. Blue line is good. Why? It keep going because of that is good. What line is good? Yeah? Check random error. Good. Our friend said random error. Your random error must be what? Less. Very good. Your error must be small. Correct or not? How to make it small? This is going back to your maths. Huh? Can you remember? Can you remember? Can you don't remember? I'm just giving a little bit clue. Okay, what do you think? A small clue. Yes? Huh? Yes? What is the clue? How? He said random error must be small. How to make the error small? You minimize the error, right? You minimize the error. Correct? How to minimize the error? You remember? How to? Okay, I just give you. You have heard function. Okay? How to make function maximum, make minimum values. Have you learned or not? You have learned that. Definitely. From 4, from 5 you would have learned. Maximum, minimum. I'm trying to connect it for you. You differentiate, make it 0, then you find that. You have to differentiate. Under differentiation topic you would have learned that. Never mind. No worries. So the same thing they are doing is. You would have learned in Form 4, Form 5 years. I think at max you would have learned that. You would have forgotten. Never mind. I don't know whether you learn in your foundation or not. Also fine. But the idea comes from there. Can you see another? Least square method. Least square method means nothing much. Your error, you square it. Why you square the error? Sometimes your value positive, actual value big, your estimated value small. You will be positive. Sometimes your actual value is big, small, your predicted value is big. So you will get negative value. Correct or not? Sometimes positive, sometimes negative. That's why you square it. Why you square it? Sometimes positive, sometimes negative. Okay? You square and then least minimum value. How to find minimum value? Okay. Did I tell you when you do linear regression, first thing you should do what? Plot. Why you plot? To check what? Whether it is linear or not. So in this case, can you say it is linear? Hey, not linear. Can what? You can put a straight line in the middle what? Okay. If not linear, the point will be here, like that. Okay? Then it's not linear. Okay? Then how well model fits it. This line is good, this line is good, or this line, okay? We don't know. Okay? So then you take your actual value. See, sometimes it will be positive. If the actual value big, your predicted value small, you minus, you get positive. Actual value small, predicted value big, you minus, you get negative. So you plus all difficult, you might get 0. Okay, so what you do? You square that. That's why you square. Okay, after square, see now. Yi. First row, second row, third row. Correct? Then you square it, your error, you square your error. This is your error. You minimize the error. The method is what? Least square error, maximum, minimum. Differentiate. I'm not going to go into that detail. But anyhow, you can see this is your first error, second error, third error, fourth error. Here only you have 4 points. So you are what you are. This is your actual value, actual value, actual value. But predicted value is this. Predicted value, predicted value, predicted. So here error 1 positive, error 2 positive. This one error 3 negative, error 4 negative. What you do? You square them. Follow? Then you differentiate. Okay, differentiation, I don't want to go on. You find your differentiation and you get the formula for beta 0 and beta 1. Follow guys? Okay, this is the connection of that. Now you should know error clearly. Are you okay with that? Okay. Okay, I don't want to do too much of theory, so then you will get bored. Okay, now let me see. Okay, so now we will look at okay, we are going to look at very fast. Okay, now I want you to give one example where we can use application of linear regression. Okay. What is it? Just now I said parameter. Before I go on, I want you to give one example of application. What is target variable? What is independent variable? Give me one example. Maybe one table, one for you to understand where are we going to use. Can you give me one? One application where you can use target linear regression. If you have done your assignment or whatever, you can give that example also. Car price prediction, okay? He wants to predict the car price. What is the explanatory variable you have? Mileage, some more? Car type, manufacturer, engine type, okay? Gearbox type, production year. See or not? So many explanatory variables. Very good. That's your assignment, is it? You all have your regression. Any example application where you can use it? They predict car price. You want to estimate or predict what? Any one of you? Yes? Yes? You have? Salary prediction. Wow, all money only. Salary prediction. Okay, that is your target variable. So what are the independent variable? Experience, education, job title, age. Very good. Okay. What about this group? Any example? Yes? You want to estimate what? Huh? Phone price. Okay, want to estimate phone price. Good. What are the independent variables? Huh? Brand, screen type, camera type, performance. Okay, that's very good. Okay, let's come back this thing. Okay. Yes. I'm going to. You have given me your target variable and independent variable. So you must connect it and tell me. Okay. Computer price money only. Okay, computer price. Okay, computer price depends on what? CPU. What? Trend or market? How do you choose the trend or market? Oh, model lah. Okay, then model. GPU, okay. RAM, okay, good, very good. Okay, we are going to interpret. You are going to interpret your data set here, huh? Okay. Okay, now your linear regression interpretation of coefficient. What is coefficient? Okay, you have slope beta 1. So it is a simple linear regression. You identify your target variable and one independent variable enough for your cases now. Okay, you have to estimate y changes when your beta 1 is 1 unit. Okay, I'm going to take the example of house price. Okay, if my house price, I calculate, I get beta 1 as 2. 2 represent 2000, not 2 only, 2000. So that means if my x go up 1, that means room go up 1, price of the house will go up 2000. That is the meaning of it. Okay? Now, then what is beta 0? In my house, no room. It's a studio unit. So, what will be the price? Sorry? What will be the price? The price will be 4,000. Hey, got a studio unit 4,000. 40,000 got now. Right? 40,000 also no. Right? Studio unit more. So, I would say 20,000 lah. If one room extra, 20,000. And no room, the price of the studio unit is 40,000. This is for P40 plan. Okay? Okay? This is how you have to interpret. Now, I'm going to ask you. Your case is car price. So take one explanatory variable. What variable you are looking? Production year. So production year, is it numerical or categorical? Categorical. So the year, that means you have to encode it, right? So then it's going to be a difficult one for you to analyze. Okay? It depends on what type. Year will be around 10 years, 30 years, so it's difficult. So we will look at the numerical variable, easy to see. Mileage, okay. One mileage go up, what will be the price range? Go down. One mileage go up, theirs is what price, how much price go down you think? You have calculated, I want you to calculate. Around? How many thousand the car price will go down? 1,000. One mileage up, 1,000. I don't know. So you are a car dealer, you know better. So yours what? You are predicting what? Huh? Predict what? Oh, you predict. Oh, price. Sorry, salary. So we look at experience. Okay. Experience, salary go up or go down?
Based on business, go up.
Huh?
Go up.
Go up. You think, did you calculate how much it went up?
Like 1 year, 1,000 or 2,000.
1,000 or 2,000. So this is what you are predicting in your, estimating. Correct? Yours is price of the phone. So give me one type. Categorical variable, much more easier. Brand. iPhone lah, Android lah, whatever. So if you buy iPhone, how much the price go up? 200? 2,000? 2,000. If you buy Android, go up 1,000. 500? 500. You understand or not? That is categorical variable. Their categorical variable difficult. You know why? So many years. Right? Difficult to see. Okay? Yours is price of the computer. What explanatory variable you want to take? Performance. How do you measure the performance level? Speed. Speed. The whole performance. Oh, low, medium, high. So low means what will be the price? Yeah. I want actual price. It goes up. Okay, you buy a computer, the basic price is $1,000. Okay, you want if the performance is low, you increase how much? 500, 200. 4 to 500. Medium, 1,000. If high, 10,000. Okay, you know already. Roughly, you know how you are measuring your coefficient. What is your coefficient? You understand or not? What is coefficient now? Correct or not? Okay, the value you give, you are what you call you are predicting more or less this amount. Correct or not? So you are mathematically calculating that. Okay, now we are done with that. So now we are going to look at one example. Birth weight of a baby depends on the estriol. This is a kind of what you call hormone in mother's body. Okay, the pregnant ladies will have estriol level. If the estriol level like this is the birth weight. Okay, if the pregnant lady don't have estriol level, that means she's not pregnant, something wrong. Okay? Okay, so first of all, we must do what? Plot the graph. Okay? You plot, what do you see? Estriol level more, birth weight is high. Okay? Target variable is your birth weight, estriol level is your explanatory variable. Okay? The formula, calculate, you get, what do you get? You get, if your beta 1 0.7, that means if your estriol, the mother's estriol level go up 1, the weight of the baby will go up 0.7. Okay, now, if the birth weight is what? If the estriol level is 0, the birth weight is -10. Make sense or not? Doesn't make sense. Why doesn't make sense? I told you earlier, pregnant lady must have estriol level, estriol in the body. Okay? It doesn't make sense in this case. Follow? Okay? Guys, you understand the interpretation of the beta 0, beta 1? Yes or no? Okay? So you should know how it works. Okay? I'm going to give one more example application. This will be a very simple application. One more linear regression. Okay, very simple application. You have a cow. You have a cow farm. Okay? I don't know how many of you have agriculture or whatever. Here, cow farm. If you give food to the cow, then the cow will give you milk. Okay? More food, more milk. I don't know. Let us do. First thing what you do. Here, target variable, milk. This is food is your independent variable. Okay? Now, you plot. Can it be a straight line? Can. Okay? So you calculate. I don't want to show. So now, you calculate what happens. Beta 1, 0.61. Beta 1, 0.61. That means, if you add 1 pound of grass, what will happen? Or food? Okay, they don't give grass or they give processed food, right? Okay? When food intake is 0, don't have food, it still gives 0.8 pound, you know. Good or not? Good. But it will give only for some time. Same you 2 days, 1 day don't eat, still can survive. 2 days don't eat, can survive. 3 days don't eat, can. 4 days, what will happen? Collapse lah. Same thing. Okay, it will give milk. But after some time, no more milk to give. Okay, you don't give food. Okay? That is the application. Now, you know how it works. Correct? I want to ask you one question. This is important. or no good? How you are going to evaluate? Please let me know. Once you have evaluated, then now whether your model good or not, I want to know how you evaluate. Some of you would have done that, but I just want to see. Evaluation is important, correct? Okay, whether your model is a good model or not. There's so many methods. Okay, let us see. R squared MAE MSC. Okay, good. R squared MAE MSC. Very good. You know about that. Okay, anonymous, very good. This person, only one person give. The others? R squared, very good. MAE, very good. Mean square. R squared means mean absolute error, mean square root error. Okay? Root means square error, good. To evaluate a linear, use metrics like R square, mean absolute, mean square error, root mean square error on test. The proper data splitting and model assumptions are met. Okay, very good. Sync metrics are like mean square. What sync metrics? Oh, using. Okay. MSC. Hey, all of you are good, no? You know what is the matrix. Do you know how to analyze? If that, all of you are very good. All of you know. Okay? Very good. 3 of you give complete answer. But do you know how to evaluate? If this value, how? Okay? Yes or no? You can answer that. If there is a absolute error certain value, R square. Okay, good. Yes or no? Okay, now I'm going to tell you if these values comes in, how to evaluate it. Okay, now that's what will be our end slide. Okay, can I? Okay? Okay now. Okay. Linear correlation coefficient. What is linear correlation coefficient? You know equation, linear here. Equation or correlation, you are looking at the relation between y and x. Correct or not? Y and x. You are looking at the relationship between y and x. Correct or not that? So, whether the relation strong or not. Strong good or not strong is good. It must be strong, right? If no strong, it doesn't give the value. So it must be strong. Okay? Okay. This one you can use it for what? Feature selection. Why? If there strong relationship, then you take the feature. If no relationship, don't take lah. You understand or not? So indirectly, linear regression can be used for feature selection also. Idea now? Feature selection. Okay? Now, correlation, you have between two variables. You can either look at the correlation by the graph or calculate the value. Okay? If you have your sample, you call it row. If you have population, you use row. If a sample R, so now you normally square it. So R square. So now interpretation of R values. You see, if your R from 0 to 0.2, not so strong. If you want to select the feature, let us say you do simple linear regression and then you get your R. 0 or 0.1. Okay, if I take price of the house and then number of rooms and then I get this, I will throw number of rooms. I won't use it as my for my model. Why? Negligible, no correlation. What's that? Okay, low degree, moderate degree. Okay, marked. If it comes from 0.8 to 1, very good. That means I have a feeling. Number of rooms and house price. If I do a model, I think I will get this. Common sense lah, right? Suddenly you see the value is like this. That means my model is something wrong. Correct or not? Okay? Okay. This is what your R point. Same thing, you will have your R square. So your R square is 0.6. 60% of the data build the model. So do you check your R square now? Always you check your R square, right? If you check your R square is 0.95, what does it mean? 95% of the data fits in that model. That means 5% only cannot, useless data. Follow? This is how you check whether your model is good or not. Okay? You can have your, your expectation, what you want to have. 90%? 80%? Okay? Depends. Another one, normally you don't look at your R square, adjusted R square. Why you use adjusted R square? You compare with your what? How many features you have. It will check. Okay, adjusted R square. This, okay, now. This also good. Beta 1, 0, beta 1, not 0. When you calculate, you will get your p-values. If your p-values less than 0.05, you reject this. You reject this means beta 1 is not 0. Beta 1 is not 0 means number of rooms and then the value not 0. That means no price go up. Isn't it? Just now I have beta 1 is what? 2,000, 20,000. So that means you have value. So you will get P will be less than 0.05. Okay? Now, you have your R, same thing goes to your normality test. Okay, now you have LRT, AIC, BIC. If you run a model in your Jupyter notebook, these are the values it will give. Okay, these values, smaller p value, LRT is better. Okay, you have smaller AIC, better. Small BIC, also better. But one model, which one is to check? You cannot check. So what? You must have two models to compare. One model, I will have two features. Another model with one feature I compare. Follow? Okay, then if smaller, I will take this model. Follow? This is how you select your models. Okay? This is how you get your price and you put the values, intercept, you calculate from your Jupyter notebook, you feed it. This one we will do in the hands-on section. Okay? Now, so that is you are checking on your model. After checking how good is your model, this is the way you are checking your MAE, MSC, root mean square, R square, mean absolute error. Okay, these are the ways you are checking to check your error. Okay, if the value is small, you say good. You have to check with two models. You prepare 2 or 3 models and then check. Check model 1, model 2, model 3. Which is the smallest? That is the best. That means your error is small. Follow? Then use that. If you are building your application, use that model create the model. 9 features, 8 features, 7 features, or combination of so many features. Follow? But start with simple linear regression also a good way. Start with 1, good, 2, 3, good. Then choose the best combination model. Then you make it, that's your best model. Follow? For your application. So before you create any AI product or any application, these are the things you should do. Follow? Why I'm emphasizing on this? This is to give you minimum error. Okay? Follow? This part is very, very important. Okay, guys? Okay, before you go into that, later I give you, this is my review. I want to ask you one question. Okay, now, do you have any question? Linear regression. You're sleepy already, I must ask you to do some activity, okay? Hey, not training evaluation. Later, I want this. Wait, not training evaluation. Okay, I want this slideshow. I want you to give me, hey, what training evaluation? Hey, training evaluation I give you. Question. You understand everything. Any doubts, any question, anything you want in the next training, or you want me to change the training method, just give me feedback here. Okay? Or you want me to end the training first? You are hungry. Huh? Okay. Anyway, I just want you to tell me about the linear regression. You are much more clearer now or how?
Yes. Yes.
Can you answer lah? Answer already. Okay. Yeah? If you really have something, it is a feedback for me also. Next, how I should tell you, explain to you. Clear and precise explanation. Okay? So after this, maybe the next training, I want you to explain. Can you explain? Okay? Okay? Clear and precise. Good. Okay? One more participant typing. I need to know whether you get what I'm supposed to give you or not. Okay? Good but hungry. Okay? Okay, another 2. I'll stop. Okay, don't worry, I'll stop. Excited, interesting training. I love it. Good. I'm hungry and sleepy, miss, but maybe can have McDonald's. Hey, McDonald's nearby? Good. Explain to linear regression. Okay? Good explanation. Can I have Heidi Lau? What is Heidi Lau? Okay, we'll go somewhere after this. Okay, now as we do the review first. Okay. Okay. Okay, guys, I want the training evaluation to be done from you. Okay? Hey, I didn't take attendance. Okay, last attendance today and okay, maybe I will give the attendance, you could just sign that. Okay? Okay, you can do the evaluation. Thank you guys for your participants. Okay, I will see you all in the next training. Okay, please put your in the website WhatsApp what do you want, then we will arrange for a training. Okay, you request what do you want? You want LLM or deep learning? You just mention. Okay, thank you guys. I'll see you in the next training.